Hi, this is Eric Loyd, master's, a master's in clinical psychology, neuropsychology concentration. I just wanted to read this uh, pretty amazing article, informative article from ncbi.nlm.nih.gov. NIH is involved in doing a lot of those really, really big studies. This one's an epidemiological study, which deals with very large groups of people over long periods of time, very long periods of time. Okay. Um, this one is from the Indian Journal of Sexually Transmitted Diseases and AIDS. Um, it's a Walter Kluver Med No Publications. This one's called Randomized Double-Blind Placebo-Controlled Studies, the gold standard in intervention-based studies. Many people might be hearing or have heard already about the gold standard for research, but that's what stands out for me whenever I see that. Randomized Double-Blind Placebo-Controlled Studies is the title, the gold standard in intervention-based studies. That's the title. The author is Shobha Misra. Shobha Misra. This one's only 8 pages, so keep it quick here. This one came out in 2012, from July to December, and that's, I think, volume 33, 33-2, page 131 through 134. And once again, that's the Indian Journal of Sexually Transmitted Diseases, AIDS, AIDS. Okay. Abstract. Studies follow a hierarchy in terms of the quality of evidence that they can provide. Randomized double-blind placebo control, that's RDBPC studies, are considered the gold standard of epidemiological studies. And the same is discussed at length in this paper, taking example of a real journal article employing this study design to answer the research question: Does once daily dose of what's that? Valacyclovir reduce the risk of transmission of genital herpes in a susceptible partner? RDBPC studies remain the most convincing research design in which randomly assigning the intervention can eliminate the influence of unknown or immeasurable confounding variables that may otherwise lead to bias and an incorrect estimate of the treatment effect. Okay, so that part's pretty significant about the reason why researchers use randomized control studies. This one is a randomized double-blind placebo control, which is even more of an exemplar study, utilizing the best that the scientific method has to offer in objectivity. Okay. Also, randomization eliminates confounding. Let me go ahead and read that again. RDBPC studies remain the most convincing research design in which randomly assigning the intervention can eliminate the influence of unknown or immeasurable confounding variables that may otherwise lead to bias and an incorrect estimate of the treatment effect. Okay, so you have two groups. One gets the treatment, one doesn't, but they don't know which one gets the treatment or which one doesn't. Okay. Also, randomization eliminates confounding by baseline variables and blinding estimates confounding by co-interventions, thus eliminating the possibility that the observed effects of intervention are due to differential use of other treatments. Okay, so that's what randomization does again. It eliminates confounding variables, which is anything that produces an effect that is not known or that is not the target of the study. So the target of the study may be to see if Tylenol works better than Advil, but there may be a confounding variable in that the individual might be doing, I don't know, let's say the individual might be doing something else, like maybe, let's say the individual might be doing some other activity that's harmful to them for whatever reason, and that might get in the way of determining which works better for pain, Advil or let's use the medical name, ibuprofen or acetaminophen. So let's say someone's doing chair yoga, right? Or someone's running 10 miles a day, right? It could be a plus or it could be a minus. Either way, it doesn't matter if it's a good or a bad. What we're talking about is the effect of confounding variable, an interaction effect, something that is getting in the way of us seeing the objectivity of this study, which one works better for pain, right? It doesn't matter if it helps or it hurts, it's something that is not accounted for, is not studied, and therefore is a confounding variable. It's not controlled for. Okay? It could be chair yoga, it could be someone's using anything at all whatsoever, good or bad, whatever it is. It would be confounding that particular study, for example. So, I'll read that again. Randomization eliminates confounding by baseline variables and binding estimates confounding by co-interventions, thus eliminating the possibility that the observed effects of the intervention are due to differential use of other treatments. So the best comparison is placebo control that allows participants, investigators, and study staff to be blinded. Blinded means that they don't know which pool that they are in, which group that they are in. Are they in the control group or are they in the treatment group? Are they in the placebo group or are they in the treatment group? Okay, they wouldn't know. The best comparison is the placebo control that allows participants, investigators, and study staff to be blinded. Okay. Okay, to be blinded. The advantage of trial over an observational study is the ability to demonstrate causality. Okay, so benefit of a trial study over just observing is that you can just demonstrate causality, right? You could demonstrate that there was a cause. That's what we call a true experiment. A true experiment. Obviously, ethically done with informed consent and everything like that. Okay, approved by maybe perhaps an IRB board, institutional review board to determine and guide the ethics of those studies. Okay, this is why these studies exist and why they're so helpful for people every single day of our lives. The advantage of the trial over an observational study, as I said, is the ability to demonstrate causality. Okay, and you do that by controlling for confounding variables. Okay. Hope this will be useful to neophyte researchers and understand causality hierarchy when critically evaluating epidemiological literature. Okay? And these keywords are blinding, clinical trials, placebo, randomization, randomized controlled trials. Causal hierarchy. Epidemiologists evaluate evidence to determine whether an exposure is directly responsible for an outcome. That's once again an experiment, true experiment, right? Trying to get a true experiment. Studies follow a hierarchy in terms of the quality of evidence that they can provide. Strongest study is the randomized controlled trial, RCT. And the same is discussed at length in this paper, taking an example of a real journal article employing this study design to answer the research question. Does once daily dose of valacyclovir reduce the risk of transmission of genital herpes in susceptible partner? In a susceptible partner. The study population being investigated was heterosexual couples who were serologically discordant for HSV2 infection from 96 study sites. So that discordant means that one has that particular virus and the other person does not have that particular virus. That's what that means. RCTs are experimental studies, also called intervention studies, randomized controlled trials, that is. RCTs. Two major types of planned experimental studies are randomized control trials, clinical trials, and community trials, community intervention trials. The basic difference between them is the unit of analysis. In randomized control trials, RTCs, this unit is the individual, whereas in community trials, it is the group. Okay? So in one, a variable is the individual or the treatment of the individual, whether it works or not, and the other one is a group. It is important to note that in preventive measurement, primary prevention, participants are healthy in whom preventative therapies are tested. Okay? So for preventative studies, they're usually healthy. Okay? The unit of analysis can be either individuals or populations. For example, polio vaccine field trial, fluoride community trial. In contrast, when therapeutic measurements, secondary or tertiary prevention are carried out on the participants, when therapeutic measurements, secondary or tertiary prevention are carried out on the participants that have a disease or condition in which therapies are tested for benefit, efficacy. Some examples are new versus old diet in diabetes, or in cancer treatment, surgical versus medical, which is coronary bypass versus drug treatment, or surgical versus surgical, in breast cancer, radical versus limited mastectomy. Okay. So those are some of the different types of studies and different types of units of analysis, okay, and therapeutic measurements and how they're used. In intervention-based clinical studies in clinical trials, the investigator applies an intervention and measures its effect on outcomes. You apply an intervention and you measure the effect on outcomes if one is an investigator doing a study. Randomized double-blind placebo control, RDBPC studies are considered the gold standard of epidemiologic studies. If well designed, they provide the strongest possible evidence of causation. To understand this clearly, it is necessary to elaborate upon the key words used in the above statement. To start with, there are prospective studies, also known as analytical studies. The investigator selects exposure of interest, say therapeutic regimen or preventative measure, and subjects are assigned at random to an exposure or the control. Then they are followed and the occurrence of outcome is compared between the two groups. Actually, the combination of randomization and blinding is the best design, but at times it can lead to ethical issues. I'm glad that they addressed that. The key words: clinical trials. Clinical trials are prospective studies in which humans are exposed to something at the discretion of the investigator and followed for an outcome. The key words: clinical trials. Clinical trials, I'll read that again, are prospective studies in which humans are exposed to something at the discretion of the investigator and followed for an outcome. Okay? The purpose is to draw inferences about the potential effect of something on a target population represented by trial participants. That's to draw inferences on the potential effect of the something on a target population represented by trial participants. So the population could be African Americans, the population could be older individuals, the population could be infants aged 3 to 5, the population could be individuals with polio, the population could be individuals with cancer, the population could be Vietnamese individuals, the population could be literally any group is a population. To explain in detail, a clinical trial is a planned experiment. 1. Designed to assess the efficacy or effectiveness. 2. Of a treatment or an intervention. 3. In men. 4. By assessing the outcomes. 5. In a group of patients or participants. 6. Treated with the test treatment and usually by comparing these outcomes with those observed in a comparable group. 7. Of patients receiving a control. And 8. Treatment. So I'll read that faster now. To explain in detail, a clinical trial is a planned experiment designed to assess the efficacy or effectiveness of a treatment or intervention in men by assessing the outcomes in a group of patients or participants treated with the test treatment and usually by comparing these outcomes with those observed in a comparable group of patients receiving a control treatment. Okay. So that tells you the population, tells you how it's doing the study. It tells you what the group is, and it tells you how the analysis is, the process works. In the definition as mentioned above, the keywords as numbered serially need further explanation. Planned experiment. The word experiment means that the exposure is determined by the investigator, planned, and is relevant. If I draw from a database all participants with X disease who were on drug A or drug B, and then compare the outcomes associated with two drugs, this is not a clinical trial. Efficacy refers to the effect of a treatment or intervention under ideal conditions. meaning, for example, all patients are compliant with the full dosage regimen, and there are no concurrent illnesses or other drugs that interfere with the outcome. Whereas effectiveness refers to the effect of a treatment or intervention under usual conditions. So that's something I just learned, the difference between efficacy and effectiveness. Effectiveness has to do with usual conditions. Efficacy is more of a true experiment. And that's good. Treatment, this is simply an exposure. You can expose a patient to a drug or a type of surgery or an exercise plan or a diagnostic device. For example, a new way of doing mammography, a mammogram. In man, whereas epidemiology can be stretched to include the study population of animals, a clinical trial, by definition, refers to an experiment conducted in humans. Okay? Epidemiology can be stretched to include the study population of all animals. A clinical trial, by definition, refers to an experiment conducted in humans. Epidemiology in humans. Outcomes. Examples are, this part is outcomes. Examples of outcomes are the resolution of disease, increased survival rate, and improvement in quality of life. Those are outcome measures. All clinical trials are prospective studies in which individuals are exposed or not and followed for an outcome. Or a few different outcomes. The outcomes must be clearly defined. Group of patients. That's number 6. This is a sample from the target population. Group of patients. It's a sample from the target population. Let's say, like the study before, individuals with polio. A sample would be a randomly selected group of 30 individuals with polio, perhaps from across the country. That would be the sample. The entire population of individuals with polio is a lot bigger than just a sample from it. Inferences will be drawn about the target population and not a specific individual studied. So inferences are drawn from the entire population, about the entire population, okay? About the entire population, not just a specific individual studied from that sample. 7, comparable group. As in any hypothesis testing epidemiologic study, a reference group is necessary. Okay? As in any hypothesis testing epidemiologic study, a reference group is necessary. This would usually be a control group or a placebo group or something like that. In a clinical trial, there is need for comparability among study groups, as lack of comparability is called confounding, explained later. So you're comparing those who get the treatment, those who are in the treatment condition or the exposure condition, and those who are not. The best way to assure comparability is by randomization. Control. In clinical trial jargon, the term control refers to a person unexposed to the test, treatment, or intervention under study. It refers to the unexposed, the person or group unexposed to the test, treatment, or intervention under study. That's control. A control may be on a placebo or on a reference treatment. A reference treatment. Okay? It is important to clarify then that an explicit control group is not always necessary to meet the definition of a clinical trial. So in this one, they used a reference treatment and not a control group because it's not always necessary to meet that definition. So is a control mandatory? The answer is studies of potential curative agents, antibiotics, of highly fatal diseases do not require a control because the untreated outcome, for example, death, is already known. Okay, so it's not known, it's not a control, is not required for studies of potential curative agents, for example, antibiotics. Or let's say in reference to COVID-19, right? That would be the same thing. Vaccine, treatment, an actual treatment, control group would not be required. Because if left untreated, the outcome, death, is already known. So in all other cases, a control is necessary. The history dates back to Sir Ronald Aylmer Fisher, the father of modern statistics. Sir Ronald Aylmer Fisher. Sir Ronald Aylmer Fisher. Ronald Aylmer Fisher. RAF. Ronald Aylmer Fisher. Almost like Ronald McDonald. Okay. Father of statistics. The father of modern statistics, who contributed to the understanding of randomization. He also made great contributions to the understanding of confounding and created designs to handle problems posed by confounding. Ronald Aylmer Fisher. Ronald Aylmer Fisher. He also made great contributions to the understanding of confounding and created designs to handle problems posed by confounding. Random and haphazard, though sometimes used interchangeably. In literal terms, haphazard is a process occurring without any apparent order or pattern, whereas statistical definition of random is assignment resulting from a chance process in which the probability of any given assignment is known. Equal chance of being in the control group or the treatment group, the exposure group or the reference treatment. 50-50. It forms the basis for the derivation of statistical tests. It's the basis of statistics in general. Very importantly, randomization avoids selection bias that could occur if either the physician or the patient chooses the treatment. It avoids selection bias. Okay. Randomization also removes, which is a confounding variable. Selection bias is a confounding variable. Randomization also removes most confounding by all known and unknown factors because it prevents an association between the treatment and any other known or unknown factor. In other words, it minimizes the possibility that the observed association between the exposure and the outcome is really caused by a third factor. Here, it is important to understand that in order to be labeled as a confounder, the potential confounding factor, PCF, must satisfy three conditions. It is associated with the study exposure. Okay, it's associated. It is the risk factor for the disease or outcome of interest, independently of exposure of interest. And it is not an intermediate step in the causal pathway between the exposure and outcome. Randomization with blinding, discussed later, avoids reporting bias. Since no one knows who's treated and who is not, and therefore all treatment groups should be treated the same. In the study article taken as example, the HSV-2 seropositive partners were randomly assigned in a 1-to-1 ratio to 500 milligrams of valacyclovir once daily or to a matching placebo. A 1-to-1 ratio is 50-50, an equal chance of being in the treatment group or the control group, right? At each visit, safer sex practices include the use of condoms during sexual intercourse were discussed with each partner. A standardized counseling was provided when signs and symptoms of genital herpes were recognized. Standardized counseling was provided when signs and symptoms of genital herpes were recognized. So they got counseling and they talked about safe sex practices. Okay. Randomization was performed at a central site in blocks of 10 to ensure balance between the groups. Randomization was stratified according to the sex and HSS-1 status of the susceptible partners. Thus, potential confounding variables minimized by randomization here could be frequency of sexual contact, frequency of condom usage, sex of susceptible partner, duration of relationship, duration of infection in source partner, etc. I'll continue the rest. It's only 3 more pages or 1 or 2 more pages, and leaving off at placebo controlled. I'll start off with that in the next video. Thank you.